Hello everyone, welcome to yet another lecture series on basics of electrical engineering. In this video, we're going to see worked examples on series RC circuit for AC supply. So let's get started. So in order to understand the problems with respect to series RC circuit, it is very important to understand the theory behind series RC circuit. So I've already made a video based on the theoretical aspect of series RC circuit behavior. So in case you have not watched that, please do watch it. The link will be provided in the description. Once you watch it, you will get a clear understanding of how the theory is associated with series RC circuit, and you will be able to correlate with these conclusions, important conclusions, and these are extremely helpful in to solve any problems with respect to series RC circuit. So let's get started. With respect to the conclusions, the voltage, as usual, it is a sinusoidal signal, that is Vm sin omega t. The current is said to be leading with respect to the voltage by an angle equal to phi. That's the reason why it is represented by phi here, a plus symbol here. And consequently, if you observe, the current is leading with respect to voltage. So that's the reason the waveform is indicated in this particular fashion. Important thing to remember is current leads with respect to voltage by an angle equal to phi in a series RC circuit. Very important conclusion. So that is what is represented in terms of phasor diagram as well. I is leading V by an angle equal to phi. The impedance with respect to series RC circuit is R minus J into XC, and it is also represented as Z at an angle of minus phi in terms of phasors. Why it is minus J? Very important conclusion, because V is lagging behind I. So with respect to V, the plus and minus symbol is written with respect to J. So here it is plus J because V is leading. Here it is minus J because V is lagging. So based on that, the expression is written with respect to R minus J XC. So the phase difference, obviously it is between 0 to 90 degree. If you carefully observe this waveform, it is somewhere 90 degree is at this point if you draw a line, but V is somewhere in between this 90 degree phase shift. So it is 0 to 90 degree, but the power factor is leading. So always you have to mention with respect to phase difference, it is between 0 to 90 degree, but it is a leading power factor, because the leading nature or lagging nature of power factor is spoken in terms of the current quantity. So current is leading, so you'll be saying it with respect to leading. So power factor, there are various definitions. So power factor is defined as cos phi. So if you have with respect to voltage triangle, impedance triangle, and power triangle, it is explained in theory. So these are the expressions. So in case they give you only the value of R and Z and ask you to find the value of the power factor, you can substitute this and directly find the value. So that's the reason why it's indicated over here. Three important definitions with respect to power: active power, the reactive power, and apparent power. These are the formulas associated with them, and the theory is explained clearly with respect to the derivations part as well. So P is equal to VI cos phi. This is the active power. So active power is the actual power consumed by the circuit due to the resistive component that is present. So it is also said to be the power loss in the circuit, or it can be say the power, it can be said that it is the power consumed in the circuit. So it totally depends on the type of power that is associated with. So now with respect to reactive power, it is the power that is associated with the capacitor. These are also called as circulating power, because they do not provide this power does not contribute to any losses. This power is mainly because of the capacitor. The capacitor stores energy and dissipates it to another component in the circuit. So based on that, the reactive power is evolved. Consequently, apparent power is the product of voltage and current, and it is represented as I square into Z. So these are important formulas. If they ask you to find the active power or the reactive power or apparent power, we need to use one of these formulas. So please make a note of all these important conclusions at a different place, and once you have made note of this, you can use this with respect to the problems on series RC circuit. So let's get started with the problems. Our first example is the voltage applied to a circuit is given as this is a voltage equation, and the current flowing in the circuit is given by this particular one. So they've given the voltage equation, they've given the current equation. Determine impedance, resistance, reactance, power factor, and power. So they've asked us all these quantities to be found out. So very important observation: the voltage is generally represented as E or V, it doesn't matter. So they've given E in this case, so we'll be taking E. And one more important observation is that they've said the voltage is applied to a circuit, and they're not as told us what type of circuit it is. So we have to identify whether it is series RL or series RC or series RLC, or depending upon what the nature of the circuit is. So how do we identify that at the first place? So they've given the voltage equation, they've given the current equation. So the angle with respect to I is 60 degree, the angle with respect to V is 30 degree. So 60 degree is greater than 30 degree, and that means I is leading with respect to E. So if I is leading with respect to E, can we say that it is a series RC circuit because the current is leading with respect to voltage? So the conclusion is it is a series RC circuit problem. Since we are already demonstrating problems related to series RC, you will be able to identify it easily. But if they ask a combination of series RL and series RC problems, you need to identify them. So that's the reason why I'm explaining this. So let us write the given data. Always it is a very good practice to write whatever is given. So initially we'll start off with writing whatever is given, and our first step is to determine the impedance. We know from the impedance formula Z is equal to V by I. So first we'll be finding the value of E and I. So E bar is nothing but in terms of phasor, that is 100 divided by root 2, that is Vm divided by root 2 at an angle 30 degree. So we'll be finding the value of E bar. We'll be finding the RMS value of current 15 divided by root 2 at an angle 60 degree. So we cannot directly take V equal to 100 or I equal to 15 because this is EM and it is not equal to E. So this is IM and it is not equal to I. So very careful observation is we have to divide it by root 2 in order to determine the RMS value of E bar and I bar respectively. And the current phase angle is given with respect to both of them. So once that is done, we know Z bar is equal to E bar by I. So substitute that both these values and solve this. You'll be getting 6.6667 at an angle of minus 30 degree. Represent them in rectangular form. It is always a good practice to represent them in both rectangular form and in polar form. So once you represent this in rectangular form, it is of the form of R minus JXC. That is because the impedance offered by a series RC circuit is R minus JXC. Can we represent this in terms of R minus J into XC? So we'll be representing it. So once that is done, so from this observation Z is given as equal to 6.67. So I'll directly be writing it as 6.67. So our next step is to determine the reactance and resistance. So from this it is very clear, this is the resistance part and this is the reactance part. So resistance is 5.77 and reactance is 3.33. So in this way, if the rectangular form of representation will help us, but polar form also helps us in different ways because phase angle phi is directly given, this is minus 30 degree. So in many ways both will be help us each in order to solve the problems related to that. So it's always a good practice to represent them in both polar form and in rectangular form. So always make this as an habit in order to solve the problems. So our next step is to determine the power factor. So as I told you, phi is already minus 30. So I will be substituting the value of power factor is equal to cos of minus 30. So cos of minus 30 or cos of plus theta or minus theta doesn't matter, so it will be the same. So 0.866, very important point. You have to mention whether it is leading or lagging with respect to any power factor problems that are given. So in this case we'll be representing it as leading because the capacitor is always associated with a leading power factor because the current is leading with respect to voltage. That's the reason why we'll be representing in this particular fashion. So very important observation. So if you're not mentioning leading, then definitely this doesn't make any sense. That's the reason why we have to mention this. So step 4 is to determine the power. So if they ask you to find the power, it is nothing but the active power in the circuit. So in case they specify apparent power or reactive power, they will be specifying them directly as kVA or kVR in any other ways as well. So power is given by the formula VEI cos phi. So in general it is VI cos phi, but here V is nothing but E as per our given data. So EI cos phi, we know the value of VIE, we know the value of I, we know the value of cos phi. Substitute them and find the value, that is 649.5 watt. This is the active power consumed in the circuit. So we have found all the values with respect to the given data. So any questions with respect to this problem, feel free to reach out. So we are into our second example now. So they've given us a series circuit. So they've mentioned it's a series circuit, consumes 2000 watt at 0.5 leading power factor when connected to 230 volt, 50 hertz AC supply. Calculate current kVA and kVAR. So careful observation, they've given a series RC circuit and we don't know if it is a series RC or series RL. They've not mentioned it anywhere, but they've given us an indirect hint. They're saying it as leading power factor. So leading power factor indicates that it is a series RC circuit. So here we will be able to conclude that it is a series RC circuit. So how do we proceed further in order to find current kV and kVR? So first write the given data that is given, that is the power that is consumed. If they're saying that it is consumed, that means it's the active power of the circuit as I mentioned earlier. So P is equal to 2000 watt. Power factor is 0.5 leading and voltage is given to be equal to 230 volt. So how do we find the current? So we know that P is equal to VI cos phi. So substitute the value of all of these and find the value of I directly. This is pretty much straightforward. By substituting the values of each of these values, you will be getting the value of I. Step 2, to determine the apparent power. So if they are writing in terms of kVA, so active power is represented as in watts, so reactive power is represented as kVAR, and apparent power is represented as kVA. So why is it kVA? It's why is it volt ampere? You can say it as volt ampere or VAR as well. So why is it volt ampere? S is equal to V into I. So product of voltage and current units, that is volt ampere. That is the reason why it is represented in this particular fashion. So S is equal to V into I. So can we represent this in this particular fashion, P by cos phi, because from this Vi, from this equation, Vi can be represented as P by cos phi. So I'm representing in this particular fashion. Why am I representing in this particular fashion? We can directly find the values, or in other words we can multiply the voltage and current that is found out as well. So there are two ways in which we can do this, but just to give you an overview, if they have not given us the value of V and I and they've given only these two values, you can find it in this particular fashion. So S is found to be equal to 4 kVA. So once this is done, our next step is to determine the reactive power of the circuit. So that is nothing but Q is equal to VI sin phi according to the formula. So the derivation, or why is it VI sin phi, is explained in the theory. So with respect to series RL circuit also it is explained. So be very careful. If you're not understanding that, please do refer to that video. So power factor is equal to cos phi. So phi is equal to cos inverse of 0.5. So they've given the power factor here. So we'll be finding the value of phi. So why we'll be finding the value of phi? Only if we know the value of phi, we can substitute it over here, because we know Vi, so only phi should be known. So substitute all the values over here: 230 volts, 17.39, sine of 60 degree. So you'll be getting 3.464 kilovolt ampere kVAR. So very important and a different type of problem this is. So practice this once. In case you find any doubts with respect to it, feel free to reach out to me. So we are into our next example, that is example 3. A resistor R is in series with a capacitor C. So clearly they have given it as a series RC circuit over here itself. First line of the problem. So is connected to 240 volt 50 hertz AC supply. Find the value of C so that R absorbs 300 watt at 100 volt. Find also the maximum charge and maximum stored energy in C. This is a very different problem. The type of questions asked with this problem is also different. So they've asked us to find the value of C so that R absorbs this particular power. That means they've given us the power indirectly and they've given the voltage corresponding to that power. They've asked us to find the maximum charge. So only if we know the value of C, we'll be able to proceed further. So we will be writing the given data. The voltage V is given as 248 and 50 hertz supply. P is given as 300 watt at uh, the voltage of 100 volt. So R absorbs this much. That means this is the active power. So as I already told you, active power is the power consumed by the resistive elements in the circuit. So P is equal to 300 watt at 100 volt. That clearly means that the voltage across the resistor VR is nothing but 100 volt. At VR equal to 100 volt, the power consumed by the circuit is 300 watt with respect to the resistor. That is what they have mentioned. So that's the reason, given data, if you write it clearly, you will be able to solve any number of problems by properly analyzing them. Our first step is to determine the capacitance. How are we going to proceed? So Xc is equal to 1 by 2 pi Fc. We know this formula. So we will be we also know that P is equal to V square V square VR square by R. So this is according to Ohm's law. So what we'll be doing is we'll first find the value of R. So once we know the value of R, our next step is we also know that P is equal to I square R according to Ohm's law. So substitute it and you will be getting the value of I. So once you know the value of I and once you know the value of R, now we know Z is equal to V by I. First substitute the value of V and I, you will be getting 80 ohms. So you know the value of Z, you know the value of R. Now we can find the value of Xc as well. So how do we do that? Xc is equal to square root of Z square minus R square. Substituting the value of Z and substituting the value of R, you will be getting 72.72 ohms. So once this is done, we know Xc is equal to 1 by 2 pi Fc. We have used this relation now. and now find the value of capacitance by substituting the values respectively. So very simple. To determine the value of C, we need to know the value of XC. So in order to know the value of XC, we need to know the value of R, and we need to know the value of Z. So we are finding it accordingly. Once that is done, we'll be finding the value of C from that. I hope how to find C is known. So now our next step is to determine the maximum charge. I have considered the voltage triangle with respect to theory. So we know that V bar is equal to VR bar plus VC bar in terms of phasor representation. So according to the formula for maximum charge, Q is we know the formula of the charge associated with respect to capacitor, Q is equal to CV. So with respect to maximum, if you're talking, you have to represent in terms of maximum. Q max is equal to CVC max. So how do we find the value of VC? It's very simple. VC is equal to square root of V square minus VR square. If we are supposed to find V is equal to square root of VR square plus VC square. So bringing the quantity in the other side, you will be getting VC, and you can substitute the value of V square that is given, and VR square is also given. So find the value of VC, that is 218.17 volt, but that doesn't mean VC is equal to VC max. So we need to find the value of VC max. So multiplied by root 2, you will be getting 308.54 volt. So VC, this is the RMS value of voltage across the capacitor. So in order to find VC max, you have to multiply it by root 2. So it is very simple. Logic is very simple. In general, if you have V is equal to Vm sin omega t as an equation, so V is different and Vm is different. RMS value will take V as Vm by root 2. So Vm is equal to V into root 2. That is the value that we are doing over here. So once we know this, we'll be able to substitute in the equation Q max is equal to C into VC max. Substitute all these values, will be getting 0.0135. That is the value of charge, that is coulomb. C is denoted as coulomb. So that is the value of the charge stored with respect to Q max. So the maximum charge we have found out. Once that is done, to determine the maximum energy stored, we have the formula E is equal to half CV square. But since they've asked us to find the maximum, we'll be representing in terms of max. So in general, E is equal to half CV square is the energy stored in case of a capacitor, and similarly in case of inductor, half Li square. So based on this, we will be substituting the value of C. We know the value of VC max as well. We'll be finding the value of E max. So 2.08 joules is the value of E max. So this is a very unique problem. A clear understanding of the analysis is very important in this. So follow the steps, you will be able to solve this. So we are into our next example, that is example 4. A capacitor of 35 microfarad is connected in series with a variable resistor. So right at the first line of our problem, they have stated that C and R are connected in series. Although they have mentioned R is a variable resistor, but it doesn't mean it is not a resistor, isn't it? So C and R are connected in series, so it's a series RC circuit problem. That is the first observation that you have to make with respect to these type of problems. The circuit is connected across 50 Hz mains. So the frequency, supply frequency is given. Find the value of resistor for a condition when the voltage across the capacitor is half the supply voltage. So they have only asked us to find the value of resistor in this problem. They have given us a condition as well. What is the condition? When the voltage across the capacitor VC is equal to half of the supply voltage. So what does that mean? I will explain it. So first up, they've given the value of C, they've given the supply frequency. This condition is when the voltage across the capacitor VC is half the supply voltage, that is equal to half into V. They have given this condition. Now they've asked us to find the value of R. That is the only thing that we have to find with respect to this problem. So just pause this video at this place and try to solve this problem on your own. If you're not able to solve that, just go through the analysis that is given here now. So to find the value of resistor, there is only one step, so I'm not writing stepwise indication of this. So VC is equal to half into V. We are writing that at the first place. So what does that imply? We know VC is equal to XC into I, that is according to Ohm's law. So I into XC, the impedance offered by a capacitor is XC. So we can write V is equal to I into R, or V is equal to I into X, or V is equal to I into Z, depending upon the nature of the component that is there. So VC is equal to I into XC, that is equal to half into V is given by I into Z. So write this. I and I will cancel out each other. So you'll be left up with XC is equal to half into Z. So Z is equal to 2 times XC. They've asked us to find the value of R. So how do we find that? We know that Z is equal to square root of R square plus XC square. So we know the value of Z is equal to 2 times XC. Substitute the value of Z as 2 into XC square. derive a relationship between xc and r. So if you solve this equation, you'll be getting r square is equal to 3 into xc square. So what does that mean? If we know the value of xc, we can find the value of r, isn't it? So we know that xc is equal to 1 by 2 pi fc for a capacitor in case of series RC circuit. So substituting, they have given us the frequency, they have given us the capacitance value as well. Substitute all these values, you will be getting 90.946 ohms. So once you find the value of xc, substitute the value of xc in this particular equation, you will be finding the value of r. So that is nothing but equal to 157.5 ohms. So this is a very tricky problem. So this is the approach that we need to follow. So they've given the data. So it's all about thinking it in the perspective of solving it with respect to the question that is asked. So be very careful with respect to these type of problems. These are very unique problems. So once you solve these type of problems, it will give you an confidence in order to approach any type of problems with respect to series RC circuit. So example 5. So a voltage of 125 volt at 50 hertz is applied across a non-inductive resistor. So they're just trying to twist a little bit. Non-inductive resistor. What does that mean? It is not inductive in nature. That means it's only a resistor. So that is what they're trying to say. It's connected in series with a capacitor. So it's a series RC circuit. Right at the first line, they have indicated what type of circuit it is. The current is 2.2 amps. The power loss in the resistor is also given. That is 96.8 watt. Calculate the resistance and capacitance. So two things that we have to find out: calculate the resistance and capacitance. What are the given data? V is given as 125 volt, the frequency supply is given as 50 hertz, I is given as to be equal to 2.2 amps. The power in this power loss in the circuit, that is nothing but the active power consumed in the circuit, that is 96.8 watt. Step 1 is to determine the value of R. So it's very straightforward in order to find the value of R. So P is equal to VI cos phi, that is equal to I square R, isn't it? So we can do it in two ways, where you can find the power factor and then find the value of Z in that particular method as demonstrated earlier. Or we know the value of P, we know the value of I, we know the value of P and I, we will be knowing the value of R directly. So P is equal to I square into R. So value of P and I is substituted and R is given by solving this particular equation. You will be getting 20 ohms. So first part of our problem is clear. We know the value of R. Now they're asking us to find the value of C. So how do we find the value of C? We know that XC is equal to square root of Z square minus R square. So we will be substituting the value of Z and we'll be substituting the value of R. So over here you can ask me, how did you find the value of Z? So it's very simple. Z is equal to V by I. Substitute and solve. If you substitute the value of V equal to 125 and divide it by 2.2, you will be getting the value of 56.82. So that is why we have directly written it. So these are extreme basics, as you have solved so many number of problems. I'm just writing it directly over here. So you'll be getting 53.18 ohms. So Xc is equal to 1 by 2 pi Fc. From this you can find the value of capacitor C, that is equal to 59.85 microfarad. I hope this problem is very simple. Just to give you a confidence on how to solve these type of problems, I have indicated a simple problem in between. That's it. So I hope this problem is clear. We'll go into our next example. Example number 6. So a resistor and a capacitor are connected across a 250 volt supply. So they've given it's a series RC circuit. So when the supply frequency is 50 hertz, the current drawn is 5 amps. When the supply frequency is increased to 60 hertz, it draws 5.8 amps. Find the values of R and C and power drawn in the second case. So they've asked us to find the value of R and C for this particular problem, and they've asked us to find the power drawn only for this particular case, for a frequency of 60 hertz and a current of 5.8 amps. So how to approach these type of problems? First step, we'll be writing the given data. They've given us the value of V, they've given us the value of F1, that is 50 hertz. I1 is nothing but the current flowing for this particular supply and frequency F1, and I2 is nothing but the current with respect to frequency F2. So once you have these data, so be very careful in substituting them. So most of the times people do mistakes of substituting F2 for F1 or F1 for F2. So be very clear and particular with respect to it. So first step is to determine the values of R and C. So how do we do it? So there is a sequence of steps in order to obtain this. So it's slightly tricky. So pay attention to this. So the frequency F1 is given as equal to 50 hertz. So we know Z1 is equal to V1 V by I1. So since it's a series circuit, the supply voltage will remain the same. So the current with respect to two different circuits will change, isn't it? So Z1 is equal to V by I1. So substitute and find the value of Z1. So we know that Z1 is equal to square root of R square plus XC square. But XC is nothing but 1 by 2 pi FC, or XC is equal to 1 by omega C. So substituting XC as 1 by 2 pi F1 into C, substitute the value of the frequency f1, that is 100 pi c square, represented in this particular equation form. So we will be taking square on both sides. We know the value of Z1, that is 50 ohms. Square of 50 is nothing but 2500. So square root gets cancelled out when you're squaring. So this would be represented as equation 1. So again we'll do the same steps with respect to f2, that is 60 hertz I've given. Z2 is equal to V by I2. Substitute 250 divided by 5.8. So what they're saying is the same supply voltage is connected when it is with respect to this thing as well. So with respect to this data, only thing is frequency is changed. So once the frequency is increased, the current is changing the circuit. So we will be constant throughout the problem. So we'll be finding Z2, that is 43.1 ohms. So Z2 is written in this term, that is R square plus 1 by 2 pi F2 into C square whole square. So once this is done, substitute the value of F2, that is 60. So you'll be getting 120 pi, that is 2 pi into 60, you'll be getting 120 pi over here. Square on both the sides. We know the value of Z2. Substitute and squaring, you will be getting this particular equation. This is equation 2. Solve equations 1 and 2, that is either by subtracting or adding them, and r square gets cancelled out, or any other method that you know with respect to mathematics. And once you solve them, you will be getting the value of R, that is 19.96 ohms, and C is equal to 69.4 microfarad. So we have found the value of R, we have found the value of C. Our next step is to determine the power drawn with respect to second case, that is for a frequency of 60 Hz and for a current of 5.8 amps. What is the power drawn? It's very simple. P2 is equal to I2 square into R. We have this direct formula. We know the value of I2 and we know the value of R. Substitute it and you will be getting 671.45 watt. I hope this is slightly different in comparison with all the other problems. So we have solved significant number of problems with respect to series RC circuit. I hope all these problems is understood by you. In case you have any questions, feel free to reach out by typing in your questions in the comment section below. If you like this video, please do like it, share it, and subscribe to our channel for regular updates. Thanks for watching this video. Please do keep supporting. Thank you.